Alright, now we're going to start Chapter 7, Section 2 of Sullivan Pre-Cal. This is inverse trig functions continued, so now we're going to talk about secant, cosecant, and cotangent, finding exact values of expressions involving inverse sine, cosine, and tangent, using a calculator to evaluate inverse secant, inverse cosecant, and inverse cotangent, and writing trig expressions as algebraic expressions. Alright, so finding the exact value of expressions involving the inverse sine, cosine, and tangent functions. Alright, here we have the angle that has, or we have a tangent theta equals 1/2. Again, what is the angle that would have a tangent of 1/2? Find the, you know that tangent is opposite over adjacent. You can make your triangle in the first quadrant since the tangent is positive. And remember, with tangent, we're looking in the fourth or first quadrant. Use Pythagorean theorem to find that the hypotenuse is the square root of 5. And so after we know the three sides of the triangle, then you can find the exact values of these trig functions. So here, find the exact value of the cosine of the angle that has a sine of -1/3. So first thing you're going to do is you're going to draw your graph. You're going to say that the angle that has a sine of -1/3, sine is between -pi/2 and pi/2. If it's negative, then it's down here in the fourth quadrant. Sine is 1/3, opposite over hypotenuse. This will be your angle. Okay, it's not a very good theta. Let's see if I can draw a better theta, or make an alpha. There's a theta. Okay. So use Pythagorean theorem then. Square root of 3 squared is 9 minus 1. That'll be the square root of 8, which will then simplify to be 2. Square root of 2 would be our x value. So the cosine of this angle that we've just drawn of the angle we've just drawn, now I'll erase my 2, okay, would be two times the square root of 2 over over 3, adjacent over hypotenuse, and so that would, you won't have to simplify or rationalize. So that would be the cosine of the angle that has a sine of -1/3. Okay, and so that's how, there's the drawing that they did, a little neater than mine, and how they found, and they got the same answer. Alright, find the exact value of the tangent of the angle that has a cosine of -1/3. So now we've got a cosine of -1/3. Well, cosine being negative, remember cosine, we look in the first or second quadrant, it's going to be negative in the second quadrant. So that's going to be -1/3. And so the same thing, square root of 9 minus 1 equals the square root of 8. So 2 times the square root of 2 will be this side. Tangent is, so tangent of theta would be adjacent, opposite over adjacent. 2 times the square root of 2 over -1. So it's going to be -2 times the square root of 2 is going to be my answer for the tangent of the angle that has a cosine of -1/3. Again, read that inverse as the angle that has. That way I think it makes it a little easier. It makes more sense. Okay? And so there's the answer to that. Same thing. Drawn better. Okay, define the inverse secant, cosecant, and cotangent functions. Alright, these same definitions apply that did for the other. It's just we have for these functions areas where the secant, cosecant, and cotangent are undefined. Cotangent is actually going to be just like tangent, essentially, because it has asymptotes at pi over 2 and negative pi over 2. Same, it goes from negative infinity to infinity in the x, and from 0 to pi, instead of negative, that's different. It's negative pi over 2 to pi over 2 in the tangent. It's from 0 to pi in the cotangent. So the domain is different. And so you may need to write down the domains for these inverse functions, and which has which. Secant is x, absolute value of x is greater than 1. So in other words, it's greater than, it's everything greater than 1 or less than negative 1. And the range is from 0 to pi, so it's in the second quadrant. Now secant, remember, matches cosine, so it makes sense that that would have the same, we're looking in the same quadrants for secant and cosine, except it can't be pi over 2 because it's undefined at pi over 2. For cosecant, again, the same thing. We're above 1 or below negative 1. It's the same quadrants, it's the sine. It matches the sine function for negative pi over 2, and y can't be 0. Again, because it's undefined. Cosecant's undefined at 0. So, find the exact value of the angle. Find the angle that has a cosecant of 2. Okay? So, again, we're looking at, you can also change it and say that's the sine, the angle that has a sine of 1/2, because it's a reciprocal function to the sine function. So the angle that has a cosecant of 2, again, cosecant positive would be in the first quadrant. Okay, it can't be 0. I think it's easier to look for the sine, the angle that has a sine of 1/2, and that's going to be pi over 6. So the angle that has a cosecant of 2 would be pi over 6. It's in the first quadrant. Okay. Calculator to find these. The secant of the angle that has a secant of 3. Okay. I would say the angle that has a cosine of 3, of 1/3, excuse me, and that's going to be should be in the first quadrant. Okay, so let's look. Again, the angle that has a cosine of 1/3 is 1.23. If you have a calculator that has the inverse secant, inverse cosine, inverse cotangent, certainly you can use it, but it's not necessary because you know it's a reciprocal function. The angle that has a cosecant of -4, that's connected to sine, so it's going to be in the fourth quadrant, should be in the fourth quadrant. The angle that has a sine of -1/4 in the fourth quadrant. Okay. So do sine -1 of -1/4, and it's -0.25. The angle that has a cotangent of 1/2 would be the angle that has a tangent of 2. Okay. Should be in the first quadrant because the cotangent's between 0 and pi. Okay. So cotangent angle has a cotangent of 1/2. Let's see, what am I looking for? There's something. Okay, I don't know. Okay, they said since we're looking for cotangent, we know it has a tangent we know it's in the first quadrant, since cotangent and tangent have different domains, we can't. They switch it to cosine because cosine and cotangent are the same domain. So if you look at the cotangent, looking at here, right here, if we draw our cotangent of 1/2, which is x over y for cotangent, figure out that the hypotenuse is square root of 5. Now we say this same angle has a cosine of 1 over square root of 5. Since you're putting it in the calculator, don't worry about rationalizing the denominator. Just do the inverse cosine of 1 over square root of 5 and get 1.11. So for cotangent, you're going to have to do something different because you can't just do the inverse tangent like I was trying to do because they don't have the same domain. Remember that tangent we look in negative pi over 2 to pi, cotangent we look at 0 to pi. So that one's a little bit different, causes a little bit of confusion. So let's look back at their next problem is another cotangent problem. Cotangent negative 2. So let's see for that. Again, they're going to look for this time it's, let's see. This time it's cotangent of negative 2. Again, since we're looking in 0 to pi, we're going to switch it to cosine. Negative 2 will be in the second quadrant. So cosine, if we have 1, 2, we have square root of 5 again as our hypotenuse. Our cosine, though, is 2 over the square root of 5. Negative, remember that 2 is negative. So we look for the inverse cosine of negative 2 over the square root of 5, which will be 2.68. So with cotangent, change it to cosine. You're going to have to use your triangle trig to do that. Write a trig expression as an algebraic expression. Sine of the angle that has a tangent of u as an algebraic expression containing u. Now these are a little tricky, but they're not terrible. So we want the sine, in this case, we need to get it to some form that we can use a trig identity on it. Well, we don't have sine and tangent in a trig identity. So we know we have tangent and secant in a trig identity. So what we're going to do, what they did, they multiply this sine. First of all, let's go back. First of all, you're going to let theta is equal to the tan negative 1 of u. So tan of theta equals u. And those are important because we're going to use those for substitutions later. Okay, so the sine of theta, then we're just going to do some playing around with these. Sine of theta times this whole piece here was replaced by theta because theta is the tangent negative 1 of u. That was our first assumption. So sine of theta now is the same as our first sine of the angle that has a tangent of u. So we're going to multiply sine of theta times cosine over cosine. This then becomes tangent times cosine. And cosine can be written 1 over secant. Now you have to kind of be able to see ahead on these. Sometimes they're not easy to see. Now we know this identity. Okay. And so we can rewrite this secant squared is equal to 1 plus tangent squared theta. So we have tangent over 1 plus tangent squared theta. And now we know this, we substitute this in there. Tangent of theta equals u. So that's where we get this u squared. So tangent of theta, for every tangent theta, okay, we replace that with u. So now we have u equals square root of 1 plus u squared as our algebraic expression. Okay, now that's the end of that one. You may need me to help you go over those algebraic expressions. You may not. There may be, hopefully you remember some of it from last semester. So your homework is on Math Excel. It's combined 7.1 and 7.2.